So for number 13, we're given, we can write vector v in terms of its magnitude, cosine theta I, plus magnitude sine theta I. So our vector v can be written as 8 times cosine 45 degrees I plus 8 times sine 45 degrees j. So that means we're going to have 8 cosine of 45 degrees is root 2 over 2i plus an 8 root 2 over 2j. So our vector v can be written as 4 root 2i plus 4 root 2j. When I graph that, 4 root 2 is approximately like 5.7. So I'm going to go over 5 and then a little bit, and then up 5 and then a little bit, right about there. So this would be the vector v, and we were writing it in terms of I and j, so I'd either leave it like that or I'd leave it like that. Actually, this one's probably the better one to use. And then drawing the picture gives me that one right down there. So for part B, we're going to do this exact same thing, except we're going to write our vector v as 5 times the cosine, 210 degrees I, plus 5 times the sine of 210 degrees j, which I kind of rough paper there. So 210 degrees is in quadrant number 3, somebody over here in quadrant number 3. So 210 degrees on the unit circle. So this would be 5 times, this is negative rad 3 over 2, I, plus 5 times negative 1/2 j. So when I simplify this, I'm getting negative 5 rad 3 over 2, I minus 5 halves j. So this is approximately like negative 4.33i minus 2.5 j. So that's only useful when graphing it. So negative 4 points and a little bit, and then down 2.5. So I'm probably right about there. So this represents my angle of 210 degrees, and the magnitude of that has to be a magnitude of 5. So the answer that I'm looking for would be that one right there.